Hello guys, welcome back to another video of Vyomkaal. So this video is in a series of continuity with the first video, the part 1 of nuclear reactions. In the first part I explained about nuclear fission, atom bombs, nuclear bombs and much more. So you should first check it out so that you can understand the things that I'm going to tell you in this video. In this video, we are going to talk about nuclear fusion, hydrogen bombs, and nuclear fission reactors. So, fusion is very different from fission. In fusion, we join atomic nuclei, whereas in fission, we split atomic nuclei. In fusion, the most common form of fusion is using hydrogen and combining two hydrogen or more hydrogen atoms to make one helium-4 atom. The most common example of fusion, nuclear fusion in our nature is the sun. The sun kind of cheats. Why? Because at the normal rate, the fusion reaction takes place at around 100 million degree kelvins, whereas the temperature of the core of the sun, where the fusion occurs, is only 15 million Kelvin in temperature. So, how is it possible that the sun is doing the fusion reaction? That is because of the pressure by the gravity of the sun. So, the sun has such immense pressure in its core that it causes the hydrogen nuclei to fuse together to form helium-4 nuclei. So why am I saying helium-4? Well, helium-4 is an isotope of helium. Isotope means that it is just the same atom but with different number of neutrons. So helium-4 has 2 protons and 2 neutrons. Adding them up gives us 4. Similarly, hydrogen also has 3 main isotopes. Protium, which has only one single proton, and it is the plain old hydrogen that we know of. The second one is deuterium, which has a single proton but an extra neutron. And the third form is tritium, which has a single proton but 2 extra neutrons. So, deuterium is much more common than tritium, and that is because of the fact that deuterium is much more stable compared to tritium. Tritium is radioactive and so it is not commonly found. Even in a single glass of water you are able to find some amount of deuterium, but tritium is very rare. So on Earth, what type of nuclear reactions do we use? We mostly use nuclear fission for bombs and the good side, which is nuclear power plants. But nuclear fusion is only being used in bombs. For nuclear fusion reactors to produce energy, it is only possible theoretically till now. The many countries are working on this, but right now there has been no result. So we are going to first start by talking about the structure of a fusion bomb, a hydrogen bomb, or an H bomb. It has many different names, but the most common one is the hydrogen bomb. It has a shell made up of beryllium. Beryllium is acting like a mirror as it deflects neutrons and X-rays and gamma rays, which will help us later out. It has 2 chambers. The first chamber is just similar to a nuclear bomb, whereas the second chamber is where the nuclear fusion happens. So this first chamber contains mainly of 2 parts: the outer covering, which is a normal chemical explosive, and the inner part, which is normally uranium or plutonium. Also, the space between these 2 chambers is filled with styrofoam. That will also help us later. And styrofoam is the same type of plastic that we use in thermocols. The second chamber has 3 parts. In the middle, there is a pole made up of plutonium. The plutonium is surrounded by lithium deuteride. Lithium deuteride is a compound of lithium and deuterium. And because tritium is very rare, we use lithium deuteride and we create tritium out of it through the use of neutrons, which we will learn about later. And finally, the lithium deuteride is covered by again a layer of uranium. So how does this work? First, the chemicals the chemical explosives are set off. The chemical explosives cause immense pressure, and because of that, the chain reaction starts and there is a nuclear fission reaction in the uranium or the plutonium of the first chamber. This emits high energy gamma rays, X rays, and also neutrons, whereas it also shock waves. But before that shock wave is able to hit the second chamber and before the bomb blast, many things happen which cause the fusion to take place. If light speed was slower and X-rays and gamma rays could not reach before the shock wave, then it wouldn't be possible for us to do fusion, because before fusion would have happened, the bomb would have already set off and lithium deuteride would have done nothing. So we start off by this reaction which releases many X-rays and gamma rays. These X-rays and gamma rays bounce off by the beryllium, which is right now acting as a mirror. They bounce off and condense and they are targeted into the second chamber. This causes the styrofoam in between to become plasma and exert pressure on the second chamber. Also, many neutrons coming from outside cause the lithium deuteride to change into a mixture of deuterium and tritium. That's where we get our tritium. A nuclear fission reaction starts happening in the uranium on the outside and the plutonium pole in the middle. Both of them start to inflate and they cause immense pressure on the lithium deuteride, which has now converted into deuterium and tritium mixture. What happens is that because of the temperatures reaching above 100 million kelvins and high pressure, the deuterium and the tritium react with each other and fuse to form helium-4 nuclei. This is how the whole bomb takes place and this is how we detonate it. But the surprising fact is that it only takes 600 billionths of a second for this to happen. In the first 500 billionths of a second, the chemical reaction along with the first chamber nuclear fission reaction happen. In the next 50 billionths of a second, the nuclear fusion starts, and after next 50 billionths of a second, the bomb has exploded and it has caused massive destruction. Now, how powerful is a hydrogen bomb? The first hydrogen bomb was discovered. We set it in a city. So a circle with a radius of about 10 miles will be completely destroyed by this bomb. Whereas the bomb dropped on Hiroshima could only destroy a radius of about 1 miles. That is the power of nuclear fusion bombs. But now we are going to look at the good side of things, that is nuclear reactors. So how do these nuclear reactors get their energy from? We use nuclear fission in them because to control nuclear fusion it is very difficult. For the nuclear reactors, we have a chamber in which the nuclear fission takes place. It has some rods to control the nuclear fission reaction so that it does not set off and become a bomb. To cool it off, to prevent it from overheating, we supply it with water. Also, the water gets converted into steam because of the heat, and then the steam with high pressure is used to run turbines, which in turn run generators, and we get electricity. Now that was a pretty simple explanation, isn't it? Well, nuclear reactors are pretty simple, aren't they? But India has made an amazing discovery in the field of nuclear power plants. Well, normally we use uranium as the fuel for the uranium power plants. But the problem is that uranium, after getting used as the fuel, leaves a lot of radioactive waste. And to store the waste properly is not an easy task, as it stays radioactive for thousands of years. But it is different for what India has done. India has discovered that the way in which we can use thorium, another element in the periodic table, which is also found naturally, but it is found in more abundant quantities rather than uranium. Also, not only it is cheap, but it also produces less amount of waste, and the amount of waste produced will only stay radioactive for a few hundreds of years. So that is the positive side of things, and India is doing a great job at it. So this was it for this video of nuclear fusion. So if you didn't understand anything, please feel free to ask me in the comment section. If you liked it, then like the video. If you loved it, then subscribe. Signing off, Satvik Pandey.